another edition of RCE. Again, this is Brock Palen. You can find us online at rce-cast.com. You can find a link there to all the back episodes, all over 100 of them, as well as you can find links to all of our Twitter channels and all of our blogs and stuff like that. Once again, I have Jeff Squyres, one of the authors of OpenMPI from Cisco Systems. Jeff, thanks again for your time.
Hey, Brock. Yeah, we're kind of continuing our little trend here of not HPC-specific topics, but things that are either related to or maybe 45 degrees off from HPC or something like this. So today we're going to be kind of talking about analytics and big data and things that actually even come out of that, which is all kind of tied together with the same kinds of things that we do.
Right. The title of the RCE is Research Computing and Engineering, and this is still very solidly into research computing space. So I'll go ahead and introduce our guest. Our guest today is Marcel Kornacker from Cloudera. Marcel, why don't you take a moment to introduce yourself?
Yes. Hi, Brock. Thanks for having me on the show. I'm the founder and architect of Impala. And I joined Cloudera in 2010 and started working on Impala in 2011.
Okay, so Impala is what we're here to talk about. Can you give us a quick overview of what is Impala?
Sure. Impala is in essence, it is an MPP database system, or rather query engine, for the Hadoop ecosystem. So it was specifically designed for living inside the Hadoop ecosystem, and thereby utilizes components of that ecosystem that you would normally find built into what are standard monolithic analytic database systems.
So let me ask the obvious question, which occurred to me and probably Brock and most of our HPC listeners out there. What's MPP?
Yes, happy to explain that. That is database industry jargon for massively parallel processing. So in essence, what that really refers to is a parallel database system that uses what is commonly considered a shared nothing architecture. And shared nothing really means that you have what is called data partition parallelism. So you take an individual query and you break it up into pieces and run the pieces on the nodes that contain the data that is relevant for that query.
I see. So, us with the HPC backgrounds, we have a particular definition of parallel computing. Yours is a little different, but very similar. It sounds like you're running code on multiple processors simultaneously, just kind of not in the same way that we're used to with traditional MPI and HPC kinds of applications. Is that right? Is that a fair characterization?
That is a fair characterization. Typically, in the database world, what you might consider a job, a query, is expressed through SQL, and SQL standard query language is structured query language is basically a form of relational algebra where you declaratively specify what you want from the query. So it is not a program that is basically, executed one statement at a time, but it's really a declaration of what you want out, logically, so to speak. And that gives you a great degree of freedom in terms of figuring out where you need to run what, and also in terms of breaking up the computation into independent pieces. So typically, when you're running a query in parallel, there are lots of large segments that do not need to interact with each other at all.
Okay, so is Impala more of... Is it a database replacement? Is it a data warehouse replacement? Or like what market is it kind of looking to... What problem is it trying to solve?
Mm-hmm. Good question. I think we should differentiate a little bit and talk about the terms database, and then also differentiate what you have in the Hadoop ecosystem versus in a more traditional analytic database system. So database system is really multiple components. It consists of a query engine. It also consists of a storage manager, and it also consists of a metadata repository. And these are all baked into one system and given to you as an analytic database system. In the Hadoop ecosystem, those are individual components. And Impala is one part of the set of components that give you database functionality. So, so Impala is really a query engine, and you would use it on top of a storage manager such as HDFS, and you also use it in conjunction with a metadata repository such as Hive Metastore. So those three components together basically give you database functionality in the Hadoop ecosystem.
Okay, so I've had some experience with Hive, and I've had experience with a few of those other tools, but they don't really feel that interactive. They feel more like an application you start up and you run some queries against, and they interact with HDFS and everything. What, what's different about Impala versus those specifically?
So when answering that question, you kind of need to look at the different origins of Hive and Impala. So Hadoop, when Hadoop started out, it was really more geared towards batch-oriented system, or entirely geared towards batch-oriented system. You had MapReduce running on top of HDFS. And Hive, when Hive came along, it basically took MapReduce as an execution mechanism and layered SQL functionality on top of that. So Hive basically translates SQL into a sequence of MapReduce jobs and then runs those jobs one after another. So in essence, you still have basically batch execution for your SQL queries, which is why you see those latencies. A lot of those latencies are basically baked into the MapReduce environment. In contrast to that, Impala is really very much like I said, a parallel database system where you do not have batch-oriented execution. A query is now translated into basically a sequence of query operators that are then sent not to MapReduce, but to an Impala daemon that runs on every node and that is always on, so to speak. And that daemon takes it and translates it and executes these. Basically, it does joins, scans, and aggregation in response to what is being sent by a coordinator node. And so what that means is that you're cutting out the batch overhead that you're getting with MapReduce. And there are also other forms of efficiency gains that we realized in Impala. And so the difference here is that with Impala, it is possible to get interactive speed. In fact, that is one of the biggest use cases for it, to basically take business intelligence tools and connect them directly to Impala and then run queries interactively against your Hadoop cluster.
Okay, so you're completely skipping Yarn and MapReduce and just going straight to the HDFS and the backend data store itself, right?
Yes, that is correct. So Yarn is somewhat outside of that. Yarn is a resource manager, and but Impala does not at present integrate with Yarn, and in particular not at the level of an individual query. Again, this is because it would add execution latency. And likewise, Impala completely skips, or I wouldn't even say skips, Impala simply does not access MapReduce in order to talk to HDFS. HDFS is a component of the Hadoop ecosystem all in itself, and has an API and can be accessed just like MapReduce does. So there's no need to have MapReduce in the mix.
So is Impala normally ran as standalone? You said you can use it to do real-time data, but like in our environment where we're kind of multi-tenant, we have multiple people, and we use some of the scheduler features to kind of enforce fairness, it sounds like Impala lets people go outside of that. So how does Impala kind of interact with a standard MapReduce environment?
So Impala is typically installed inside standard MapReduce environment. It basically shares resources with a Hadoop cluster. The way this is typically done is through Cloudera Manager, which allows you to set up Impala side by side with MapReduce on the same nodes using Linux containers. So you basically get resource partitioning, but you're still staying on the same node. So you would basically say, I have 64, 128 gigs of memory available on a node, and you would decide a certain fraction of that should be dedicated to Impala.
Are there other forms of resource management that Impala does? So again, I'm coming